A vessel of volume V equals to 6.0 liter contains water together with a saturated vapor under a pressure of 14 atmospheric and at a temperature of 50 degrees Celsius. The specific volume of the vapor is equal to V dash V equal to 50 liter per kg. Under this condition, the total mass of the system water vapor equals m equals to 5.0 kg. Find the mass and the volume of the vapor. Given according to the question, volume of vessel V equals to 6.0 liter 16 10 to the power minus 3 meter cube. A specific volume of vapor VV dash equals to 50 liter per kg, 50 into 10 to the power minus 3 meter cube per kg. Total mass of the water vapor m equals to 5 kg. Let m dash is the mass of vapor. Hence total volume of vapor m dash into Vv dash, and also total volume of water m double dash into Vi dash, where m double dash mass of water and Vi dash a specific volume of the liquid water. Now V equals to m dash Vv dash plus m dash Vi dash, and also m equals to m dash plus m double dash. Question 2. Solving these two equations and 1 and 2, we have V equals to m minus m double dash into Vv dash. This implies V minus m into V dash equals to m double dash under bracket Vi dash minus Vv dash. Hence m double dash equals to under bracket V minus m into Vv dash divided by under bracket Vi dash minus Vi dash Vv dash. Hence m dash is equal to m minus m double dash equals to m minus under bracket V minus m into Vv dash by under bracket V dash minus Vv dash equals to V minus mvi dash divided by Vv dash minus Vi dash. Putting the values of all V, V1, Vi dash and Vv dash, we can get mv equal to 20 gram. Hence volume Vv equals to mv by Vv dash equals to 1.1 liter. The saturated water vapor is enclosed in a cylinder under a piston and occupies a volume V0 equals to 5.0 liter at the temperature T equals to 100 degrees Celsius. Find the mass of the liquid phase formed after the volume under the piston decreased isothermally to V equals to 1.6 liter. The saturated vapor is assumed to be ideal. Since the volume is decreased and work is done on the gas, as a result of this, pressure increases and the vapor is liquefied. The process is isothermal. Since the vapor is ideal, hence P into V naught equals to Mi by M equals to RT. Question 2. And PV equals to MF by M into RT. Subtracting equation 2 and 3, P into V naught minus V equals to under bracket Mi minus MF by M into R into T. Hence Mi minus MF equals to delta M, which is the amount of vapor liquid filled. Hence delta M equals to P into V naught minus V into M by RT. Putting all the values of P saturated atmospheric pressure equals to 1.013 into 10 to the power 5 Newton per meter square. Again, m equals to 18, r equals to 8.31 joule per Kelvin mole, and T equals to 100 plus 273, 373. So V naught equal to 5 liter, 5 into 10 to the power minus 3 meter cube, and V equal to 7.6 liter, 1.6 into 10 to the power minus 3 meter cube. We get V equal to 7.6 liter, 1.6 into 10 to the power 3 meter cube. We get delta M equals to 2 gram. A volume occupied by a saturated vapor is reduced isothermally n-fold. Find what fraction eta of the final volume is occupied by the liquid phase if the specific volumes of the saturated vapor and the liquid phase differs by n times. Under bracket n greater than n. Solve the same problem under the condition that the final volume of the substances correspond to the midpoint of a horizontal portion of the isothermal line in the diagram PV. Let a specific volume of saturated vapor is V1 dash and that of liquid phase V2 dash. According to the question, V2 dash by V1 dash equals to n. When the volume occupied by saturated vapor V1 dash is reduced n-fold, let final specific volume the saturated vapor V1 and that of liquid V2. Hence V1 equals to V1 dash by n, equation 2. We have to find eta equals to V2 by V1. Now from equation 1, V2 dash minus V1 dash by V1 dash equals to n minus 1. Again V1 by V1 dash equals to 1 by n. This implies V1 dash vata V1 dash equals to n. This implies V1 dash minus V1 by V1 equals to n minus 1. Since when the volume of saturated vapor is reduced, the vapor will condense by volume V2 equals to V1 dash minus V1. Similarly, the second part can be calculated eta equals to 1 by under bracket n cap n plus 1. Answer. An amount of water of mass m equals to 1 kg boiling at standard atmospheric pressure turns completely into saturated vapor. Assuming the saturated vapor to be an ideal gas, find the increment of entropy and internal energy of the system. We have, according to the question, mass m equals to 1 kg, which boils at P naught 1.013 into 10 to the power 5 Newton per meter square. All the water is turned into saturated vapor. Hence, during this process, the temperature of the system remains constant, that is T equals to 100 degrees Celsius, or T equals to 273 plus 100, 373 degree Kelvin. This change of state occurs by taking only latent heat of vaporization. Now, dq equals to mq, where q is the latent heat of vaporization. Hence, change in entropy delta S equals to dq by T equals to m into q by T. Now, from the first law of thermodynamics, dq equals d plus dw, where dq heat transfer, d change in internal energy, and dw work transfer. Hence, d equals to dq minus dw equals to m into q minus nRT, as A equals to PV equals to nRT. This implies hence equals to m into q minus m by m into RT equals to m into under bracket q minus RT by m. Putting all the values, that is m equals to 1.0 kg, T equals to 373 Kelvin, R equals to 8.31 joule per mole per Kelvin, and m equals to 18. We get q equals to 2250 joule per gram. we get delta S equals to 6.0 kilojoule and delta E or delta U equals to 2.1 mjoule.